Hello friends, welcome to the next aspect of functions of coating under the edges of polymer process engineering. In the previous lecture, we have covered the coating as an insulation and dielectrics. Then we discussed about the electrical properties, the different useful concepts. Then we talked about the resistance and resistivity, effect of variables on resistivity we discussed about. Then molecularly conductive polymers we had taken into consideration. We talked about the metal filled polymers, then discussed about the capacitance and dielectric constants and dissipation factor and power law. In this particular segment, we are going to discuss about the environmental protection through the coatings. Under this edge, we discuss about the protection against moisture, water absorption. We'll talk about the humidity testing, protection against corrosion, discuss about the wash primers, mechanical protection, protection against electromagnetic and radio frequency. Then we'll talk about the protection against the electrostatic discharge. Then microbial protection, thermal conductivity and its testing procedures. We will discuss all these things in this particular segment. Now, let us talk about the environmental protection, the protection against moisture. That is, a coating for printed circuits, electronic assemblies play a very crucial role in preventing corrosion and breakdown of electrical insulation by acting as moisture and gas barriers. While coating cannot provide the true hermetic seals like welded metals packages, it is possible to select the plastic coating that reduces the moisture penetration enough to meet long-term storage and operational requirements. Now, sometimes failure caused by the moisture penetration, this can be categorized into two types. One is the moisture mobilizes the ionic contaminants leading to the deterioration of electrical insulation and formation of inversion layers in semiconductor device. Then the moisture in the presence of impurity ion allows the electrolytic corrosion to occur. Now, active and passive devices like transistor, diodes, resistors, they are typically hermetically sealed in metal packages, while entire electronic assemblies are sealed in dry inert gas atmosphere to prevent these failures. The hermetic sealing is expensive and not practical for most commercial applications. So, organic coatings or plastic encapsulants are used as alternative protection measures. The quantitative values for water resistance of organic coating, they are essential and can be defined based on three factors: the percentage absorption of water by the coating at a constant temperature over time, rate of water vapor transmission through the coating, the functioning of coated electronic assemblies after a simulated or accelerated humidity recycling test. Let us talk about the water absorption. The coating exhibits the varying degree of water absorption influenced by their molecular structure and degree of cure. Now, coating resins containing hydrophilic polar group or low molecular weight water soluble additives tend to have a higher water absorption values. The semi-rigid coating generally absorb more water compared to high cross-linked water system. And the water absorption, this reaches as a constant percent at a constant temperature for each material, typically achieved say after 1 or more weeks of immersion. Now, certain coatings such as polyurethane initially reach maximum water absorption and absorptive value, but lose weight and stabilize at a lower equilibrium value, potentially due to the leaching of water soluble additive or trapped solvents. For practical application, 24-hour data, they are meaningful for any kind of a test conditions. They serve as more severe or actual operating conditions. So, the percentage of water absorption alone is not sufficient indicator and it should be considered in relation to detrimental effect on coating and the protected part. The water absorption is critical for insulation properties or especially electrical insulating properties, but it is not the sole factor. Ionic impurities and the polar nature of the coating also contribute to the effect, and some coating experience adverse effects on electrical properties with even a small amount of water absorption, while others with high water absorption may remain stable electrically. Now here you see that the water absorption values for various epoxies like araldite, this is which is the commercial name 502 and araldite 6010. The curing schedule is given in this particular column, and water absorption at 1 hour and 100 degrees Celsius and 10 days and 100 degrees Celsius. You can see the difference. Similarly, if we take the other segment, then you see the difference in the water absorptivity. Let us talk about the permeability. Moisture can penetrate a coating through two mechanisms. The first mechanism involves the passage of moisture through micro cracks, channels, or pinholes that result the physical imperfection in the coating. And the presence of pinholes and pores can significantly reduce by applying the moisture coats of the same material. And the second mechanism, this involves the inherent molecular structure of polymer, where water vapor molecules permeate the spaces between the polymer molecules and within the polymer structure. This permeability, known as the moisture vapor transmission rate or MVTR, this refers to the ability of a material or coating to allow the passage of water vapor through its structure. Now, it is a measure of the rate at which the moisture can permeate through a material over a specific area and a time period. This typically expressed in units such as gram per square meter per day, and this MVTR is equal to QL over AT, where Q is the water vapor permeating the film in grams, L is the film thickness, A is the film area, and T is the time. The lower permeability value indicates a material that is less permeable to moisture vapor, while a higher permeability value indicates a material that allows greater moisture vapor transmission. The permeability of a material is influenced by factors such as the molecular structure, thickness, temperature, humidity gradient, and any other barrier or coating applied to that particular surface. The permeability of a coating is influenced by various factors and the type and amount of the pigment or filler used. In general, the pigmented coating have the lower permeabilities compared to the unpigmented coatings, because the water molecule have to travel a longer path to penetrate the film thickness. The nature of pigment also play a very vital role. Apart from this, its geometry, that is whether it is a spherical or a flat, and the packing density, all affects the moisture permeability of the coating. So, for instance, the flake-shaped pigments like aluminum, this can significantly improve the resistance to moisture penetration. Now, the permeability values tend to decrease as the pigment concentration increases until reaching a minimum at a crucial pigment volume ratio. Beyond this ratio, the permeability sharply rises. The moisture permeability properties of the polymer coatings, they are commonly quantified using moisture vapor transmission rate, and this can be discussed in due course of a time. Now, in this particular table, there are various factors we have enlisted, those affecting the moisture permeability, like solvent entrapment, this increases the permeability, then the plasticizer increases the permeability, then the structure of film like polar hydrophobic, polar hydrophilic and non-polar, they decreases, increases and decrease respectively, and then degree of cross-linking decreases the permeability, and crystallinity again it decreases the permeability. Let us talk about the humidity testing. The humidity testing for the polymers in electronics is a crucial step in assessing their performance and reliability in a humid equipment. It involves subjecting to the polymer materials or electronic component to controlled humidity condition to evaluate their resistance to moisture absorption, dimensional changes, electrical properties and overall durability. The humidity testing process, this typically follows the various standard protocols like ASTM D2247 or IEC 6006823. Now, the common humidity testing methods, this includes the constant humidity test. This involves exposing the polymer or electronic component to a constant humidity test for a specified duration. The relative humidity is maintained at a set level and typically ranging from 85% to 95% depending on the specific test requirement. And the temperature humidity cyclic test. This is again subjected to the samples of the cyclic change in both temperature and humidity, and the specimens are exposed to alternating high and low humidity levels. Now, this test is useful for evaluating the performance of materials under moisture induced stress and thermal cycling. Now, during humidity testing, various parameters are monitored and evaluated. This includes the weight gain or loss, the change in the weight or the sample due to the moisture absorption or desorption, then dimensional changes, the measurement of the size or the shape change of the material, which can indicate the potential of wrapping, swelling and shrinkage. Electrical properties, the assessment of the conductivity, insulation resistance, dielectric strength and other electrical characteristics which may be affected by moisture. Visual inspection, the examination of the sample for signs or delamination, blistering, cracking and other visible factors. Now, let us talk about the protection against corrosion. When it comes to corrosion prevention in electronic component, various polymer coatings methods are employed for protecting metals and alloys. Now, these methods provides a barrier between the metal surface and the corrosive environment and preventing or slowing down the corrosion process. Now, some of the commonly used coating methods for corrosion prevention, they are enlisted. One is the dip coating. Dip coating, this involves the immersing of the metal or alloy component into a liquid polymer solution or dispersion such as epoxy or a polyurethane coating. The component is then slowly withdrawn and allowing excess coating material to drain off and then cured to form a protective film. This is the most cost effective method suitable for coating large quantities of component with uniform thickness. Another thing is that spray coating. This is the technique where the polymer coating material is atomized and sprayed onto the metal surface using specialized spray equipment, and this method allows for the precise control over the coating thickness and uniformity. This spray coating is commonly used for coating complex shaped component and offers a good coverage and adhesion. The electrostatic powder coating. In this method, the electrically charged polymer powder particles are sprayed onto the metal surface and the metal component is grounded, attracting the charged powder particles which adhere to surface, and the coated component is then heated to melt and cure the powder, forming a durable and uniform coating. The electrostatic powder coating provides excellent coverage, adhesion and resistance to chemical and UV degradation. Electrophoretic deposition, EPD. This is the process where a metal component is immersed in the bath containing a polymer dispersed with the charged particles. When an electric field is applied to the charged particle, migrate and deposit onto the metal surface, forming a conformal coating, EPD of conformal coating. Now, this EPD offers excellent coverage, uniformity and control over coating thickness. Then CVD, that is chemical vapor deposition. This is a vapor phase coating method where a precursor gas containing polymer molecule is introduced into a chamber containing the metal component by chemical reactions, and the polymer molecules are deposited over the surface forming a thin conformal coating. This CVD provides excellent coverage, adhesion and uniformity, particularly for the complex geometries. Let us talk about the metal and alloy protection. The magnesium. This is a lightweight metal that is known to be highly susceptible to corrosion when exposed to moisture, oxygen and other corrosive environment. The magnesium can undergo a rapid corrosion leading to the material degradation and structural weakening. Therefore, implementing the effective corrosion protection measure for magnesium is crucial. Now, there are some common methods we are going to discuss for the protecting magnesium against corrosion. One is the surface coating, that is applying the protective coating on the surface of magnesium is widely used method for corrosion protection. And different type of the coating such as organic coating like paints, inorganic coating like conversion coating, electroplated coating. This can provide a barrier between the magnesium substrate and corrosive environment. Anodizing, this is the process that forms a controlled oxide layer on the surface of magnesium through the electrolysis, and this oxide layer acts as a protective barrier, improving corrosion resistance and enhancing the aesthetic of the magnesium surface. This anodizing can be combined with the coloring or sealing processes to provide the additional protection. Alloying magnesium with other element can enhance the corrosion resistance. For like example of addition of aluminum in the form of aluminum alloy to the magnesium, this can improve its corrosion resistance by forming a protective oxide layer on the surface. Galvanic protection. This galvanic protection involves using the sacrificial anodes to protect the magnesium from corrosion, and by connecting more reactive material to the magnesium, the sacrificial anode the corrodes, the preferentially protecting the magnesium from corrosion. There are certain corrosion inhibitors. This can be used to reduce the corrosion rate of magnesium. These inhibitors can be applied as a coating and incorporated into the protective film or used as adhesive in the corrosive environment. And these inhibitors works by forming a protective layer on the magnesium surface or by altering the electrochemical reactions. Environmental control, the controlling the environment condition in which the magnesium is used can help prevent the corrosion, and this includes the minimizing the exposure to the moisture, humidity, corrosive chemicals, and proper ventilation, drainage, moisture control. This can also be contribute towards the reducing the risk of corrosion. Regular maintenance is again very integral part. Regular inspection, housekeeping, cleaning, maintenance, they are important for identifying the addressing any sign of magnesium surface. Now, it is essential to select and implement the appropriate corrosion protection methodology based on the specific application, environmental conditions, requirements, and by employing the effective corrosion protection measures, magnesium can be safeguarded, ensuring the durability, performance, and safety in various applications. Then tin lead shoulders. This tin lead shoulders is commonly used material for joining the electrical components, plumbing applications, and other soldering processes. And tin lead solder, they are susceptible to the corrosion when exposed to certain environment, especially in the presence of moisture, oxygen, and other corrosive elements. To protect tin lead solder against the corrosion, several mechanisms can be adopted. One is the flux selection. Flux is a critical component in soldering that helps to clean the surface being joined and promoted proper wetting and bonding with the solder. Now, choosing the appropriate flux for tin lead soldering is essential to prevent the corrosion. Proper cleaning. Prior to soldering, it is important to clean the surfaces to be soldered to remove any contaminants or oxides, oil, which can hinder the proper bonding and lead the corrosion. Solder alloy selection is again very important. While tin lead solder has a good soldering properties, it is more prone towards the corrosion compared to some other solder alloys. Consideration can be given to the alternative solder alloys for better corrosion resistance, which are lead free solders like tin silver copper or tin copper alloys. Coating or encapsulation. Applying a protective coating or encapsulating the solder joints, this can provide an additional layer or protection against corrosion. This can be done using conformal coating, epoxy resin, or other protective material that act as a barrier between the solder and corrosive environment. Obviously, the environmental control plays a very vital role, which we have already discussed, that proper storage, handling, installation practices, humidity control, all these play a very vital role. Regular inspection also, inspection and maintenance, this also plays a very vital role in such kind of the protection against corrosion. And it is important to note that the tin solder is regulated to many reasons due to its lead content, and there is a global trend towards the use of lead free solder alloy. However, for the application where tin lead solder is still in use, implementing and mentioning protection measures, this can help the minimization under the corrosion environment. This ensures the reliability and longevity of the solder connections. Let us talk about the aluminum. Like magnesium, aluminum is widely used because of the low density. It is too much, it too must be protected from the corrosion, although the normal oxide film which forms on its surface on exposure to air is highly protective and prevents the deterioration of the bulk of the metal. A number of oxide coating anodized, this may purposely be formed as a protective coating and the surface treatment to improve the adhesion of the subsequent organic coating. Primers such as wash primers, phenolic epoxies, they are useful in serving the bridge between the anodized surface and the top coat pen. As with magnesium, epoxy primers and epoxy or acrylic top coats with the outstanding long-term corrosion protections. So, this can be used. Now, let us talk about the magnesium lithium alloys. Magnesium lithium alloys, sometimes referred as La141, they are attractive to the designers of airborne electronic equipments because of their stiffness and high strength to weight ratio. These alloys offer 20 to 25% weight saving over magnesium and other magnesium alloy. Now, the high reactivity of magnesium lithium with the moisture and carbon dioxide limits its use to hermetically sealed boxes with the dry inert gas ambient. Often, even in an enclosed box, an incompatible situation can arise owing the evolution of moisture from the plastic or from the electronic component within the box. So, the moisture reacts with the lithium portion of the alloy, forming the hydrogen gas and a lithium hydroxide in the presence of the carbon dioxide, while white lithium carbonate is formed on the alloy surface. And in addition to the formation of these corrosive products, and the deterioration of the alloy, a secondary, perhaps the even more harmful effect may result from reaction to evolve the hydrogen gas with active devices, chemically sensitive, thick or thin film resistance and other components. Although there are reported to be several coatings which will protect magnesium lithium in normal environment, no organic coating or coating system is known to provide the sufficient protection to the pass the military environment test. Now, here in this particular aspect, we have discussed with the different type of wash primers. The wash primer consists of rust inhibiting pigment, mainly basic zinc chromate or lead chromate in an alcoholic solution of polyvinyl butyryl resin as one part or a two part of system. The second part consists of a phosphoric acid water isopropyl alcohol solution. Now, these wash primers may be used alone or where the superior protection against the salt spray or moisture is required in conjunction with the top coat such as epoxy, vinyl or alkyd. A wash primer top coat system provides protection for either magnesium or aluminum for over 800 hours of salt spray exposure. Over 2000 hours of salt spray exposure without deterioration has been reported by some of the scientists for vinyl coating applied over either wash primer or a red lead primer. Other type of primers are also employed to improve adhesion of top coats, hence provide better corrosion protection, and the performance of a vinyl coating, for instance, is greatly improved by priming metal surface. Now, the primers may consist of other specifically formulated vinyl phenolics, epoxies and butadienes, acrylonitriles. These epoxy primers are very effective in improving the adhesion of the polyurethanes and in the protection of the either aluminum or steel. The use of an epoxy primer followed by the top coat of moisture curing polyurethane resulted in panel which passed say 800 hours of 20% salt spray exposure as per ASTM standards. Now these epoxy primers, some of the primer formulation is enlisted. Now epoxy primers may consist of normal coating which have been thinned further and sprayed on a very thin or coating formulated to contain a number of ingredients like we have enlisted some of them over here. Let us talk about the mechanical protection. The mechanical protection is an important safeguard material in a structure form and a various form of the damage including wear and tear, impact, abrasion, deformation. The mechanical protection measures aim to enhance the strength, durability and integrity of the protected component. Now, some of the common methods for mechanical protections are given like protective coating, applying the protective coating like paint, sealant or a film. This can provide a physical barrier that shield the surface from mechanical damage. Then reinforcement, the incorporation of a reinforcement in the form of a fiber, fabrics, meshes. This can enhance the mechanical strength and impact resistance of the material. Then impact absorbing materials, now using the impact absorbing materials such as rubber or a foam, this can provide the cushioning and absorb the energy of impact. And these materials, they are commonly used in the application where protection against impact or shock is crucial. Structural design, the implementing appropriate structural design principle can help distribute loads and stresses evenly and reducing the risk of mechanical failure. This includes the designing component with sufficient strength, stiffness and a load bearing capacity based on the expected operating conditions. The reinforced enclosures, the enclosing sensitive components or structure within the reinforced casing or enclosure can provide the protection against the mechanical impacts, vibration, etc. Then protective covers and guard. This can shield the vulnerable component from direct contact with the external object or substance. Then the shock mounts. Utilizing shock mounts or isolators, this can reduce the transmission of the vibration, shocks and impacts from the external environment to the sensitive component. Then the maintenance and inspection, the regular maintenance, inspection and a repair of mechanical system, they are quite essential to identify and address the potential area of weakness or damage. Now, abrasion resistance, the application in which there is an excessive handling, rubbing, contact with other object, this requires the surface to have a high degree of abrasion resistance. This may be determined by the periodic examination while the coating is in actual use. Now, this includes the projection of a controlled stream or abrasive such as carborundum or a sand, this against the sample. Now, here this is the Tabor abrasion resistance. Now, this method is referred is the most widely used for the plastic coating and described in the various standards. The panel, usually the pre-weight to the nearest milligram is placed on the turnable operating condition at a constant speed, while two abrading wheels are fixed on each side of the spindle and direct contact with the coating. So, roughly 1000 gram of a load may be placed on wheels and a built-in tachometer records a number of turnable revolution and a vacuum attachment removes the plastic particles as they are abraded from the surface, and the instrument is operated for a specific number of cycles or until a portion of the substrate becomes exposed. The result may be reported in either a number of cycles to failure per mil thickness of coating or the weight loss in the milligram for a specified number of cycles. Friction resistance, when repeating sliding or the insertions, this must take place as in the electronic drawers or consoles surface with a low coefficient of friction. This will facilitate the operation with and will minimize the surface abrasion and deterioration of coating. The best way to assess the friction resistance of the material is by comparing their coefficient of friction. The lower this value, the greater the resistance, and theoretical treatment of both friction and abrasion, which can be reported over here. Now, in this particular table, we have reported the coefficient of friction with the typical coating. Now, here these are the coating, and you can see the different coefficient of friction. Now, the coefficient of friction, let us for an example, varies for nylon varies from 0.91 to 1.19 with the variation of the moisture content from 2.2 to 10%. The surface against which the sample is tested is also an important variable. Hardness. Hardness is again an important property of in the mechanical protection. It is the measure. It measures a material's resistance to the indentation, scratching or deformation. A high level of hardness can enhance the durability and the wear resistance of material, making them more capable of withstanding the external forces and reducing the risk of damage. Here are some ways in which the hardness contributes to the mechanical protection. One is the wear resistance. The materials with the high hardness exhibit an improved wear resistance as they are less susceptible to the surface damage and deformation caused by the frictional forces. Scratch resistance. Hardness display a very crucial role in preventing the surface scratching and marring. The materials with high hardness, they are less prone to scratch from the contact with a sharp object or abrasive particles. Impact resistance. Although the hardness is a primary associated with the resistance to indentation, and it can also indirectly contribute to impact resistance. The hard materials are less likely to deform or dent when subjected to impact or high pressure forces, providing the better protection and underlying component structure. Cutting and machining performance, component strength, all these things play a very vital role. The surface protection, applying the hard coating, this prevents the surface. This is a usual practice. Then structural stability. The hard materials, they are less likely to undergo the plastic deformation, to creep under mechanical load, ensuring the structural stability of the component and preventing the dimensional changes that could compromise the functionality to fit. Now, let us talk about the protection against electromagnetic and radio frequency interface. The electromagnetic and radio frequency interface pose risk of electrical failure and disruption to the sensitive electronics, and this can be caused by the electrically incompatible part within the system and external spectrum pollution. Now, plastic with the conductive material, they are commonly used for EMI and RFI shielding, and silver is the most frequent used metal filler, followed by the nickel, copper, stainless steel, carbon fiber, carbon black coated graphites, and aluminum flake and fibers. Here are some of the typical examples of the product used for EMI or RFI protection, like different type of elastomer oriented with wire, then the plastic fillers, then shielding performance. So, the test method which is given as per this standards. Now, let us talk about the electrostatic protection against the electrostatic discharge. Now, each year millions of dollars, they are lost by the electronics industry because of electrostatic damage to devices and circuits, and this loss can come from the damage of the semiconductor devices, causing a product to fail, or in more extreme cases an explosion due to the static spark in a combustible atmosphere. Now, to minimize this problem, the electrostatic sensitive devices like integrated circuits, transistors and diodes are stored and transported in specially treated plastic enclosures. Now, in order to dissipate the electrostatic charge that develops on the plastic surface, the plastic must be formulated or coated with electrically conductive or semiconductive fillers such as graphites or ionic surfactants such as long chain fatty amines or carboxylic acids. Let us talk about the microbial protection. Microbial protection is an important aspect of a mechanical protection in various applications, particularly in the industry, where the growth of microorganisms, this can pose risk of human health, product integrity and the system functionality. Now, some of the ways in which the microbial protection is incorporated. One is the antimicrobial coating. This you can apply the antimicrobial coating on the surface. This helps to inhibit the growth or spread of a microorganism. Then we must go for the hygienic design by incorporating the hygienic design principle in mechanical system or equipment. This can be prevent the accumulation of microorganisms. Then smooth and non-porous surfaces. These the surfaces that are smooth and non-porous, they are less likely to harbor the microorganism compared to the rough and porous surfaces. Then sealant and gaskets. The proper sealing of mechanical component or system using the sealant and gasket, this can prevent the entry of microorganism into the sensitive areas. By adoption of regular cleaning and maintenance practice, the regular cleaning and maintenance procedures, they are quite essential to remove the microbial contaminants and maintain a clean and hygienic environment. Then the proper material selection, the choosing the material with the inherent antimicrobial properties can provide the built-in microbial protection. Then UVC sterilization, then a certain application, the ultraviolet C light technology can be used to provide the microbial protection. Now, polymers play a crucial role in providing the microbial protection of electronic components by acting as a barrier against the microbial growth and preventing the contamination. They are used in the various forms like coating, films, adhesive to create the protective layer that inhibits the growth and survival of microorganisms. One is the silver based polymer. Silver is excellent antimicrobial properties. It can be incorporated into the polymer to enhance their microbial protection capabilities. Then quaternary ammonium compounds, they are also used as antimicrobial agent in the polymer formulation, and these compounds have positively charged quaternary ammonium group that interacts with the negatively charged microbial cell membranes and disrupting the integrity and leading to cell death. The polymeric biocides, the certain polymers are formulated with specific biocidal additives to impart the antimicrobial properties, and these additives release the active ingredient that target and inhibits the microbial growth. Sometimes antimicrobial silicon rubbers, this can be modified with the antimicrobial agent to create the antimicrobial silicon products. Then antimicrobial films, the polymer films such as polyethylene, polypropylene or polyvinyl chloride, these can be modified with antimicrobial agents to create the protective film that can be applied to the electronic components. And to test, various testing protocols are available. Let us talk about the thermal conductivity. Thermal conductivity, the total quantum of amount of heat and the material can conduct, this is directly proportional to the surface area and time of contact and temperature gradient, and which is inversely proportional to the thickness and sample. And this is the mathematical representation given for the total heat flow. There are various test methods measuring the thermal conductivities are available, for which the guarded hot plate and a heat flow method, they are most widely used. Now, this is one of the example of the guarded hot plate apparatus. The guard section ensures the unidirectional heat flow from the central heater and eliminates any influence from the edge of the sample. To evaluate the thermal conductivity, we have given several references in the reference section. You can go through for the further reading. Apart from this, the heat flow meter method is again useful to evaluate the thermal conductivity, and for all these studies we have enlisted several references and which you can use for your convenience. Thank you very much.